Hello dear students, so you know that we are discussing this previous year questions on acceleration due to gravity. Okay, so we'll be continuing with that. Okay, so here on the screen there is question number 4. We'll be discussing here this very question. Okay, beta? So this question has been asked in the NEET 2017. So let's discuss this question. So first of all, what's given to you is this acceleration due to gravity at a height of 1 kilometer above the earth is same as that at the depth d below the surface of earth. So this is actually below the surface of earth. Here it's below the surface of earth. ठीक है ना बेटा? Surface of earth, then d is equal to, you are supposed to calculate the value of this d into h is equal to 1 kilometer. Okay, तो इसके लिए आपको याद क्या रखना है बेटा? Acceleration due to gravity, it decreases with depth as well as due to height. It decreases with the depth as well as height. Okay, but the acceleration due to gravity decreases more rapidly with the height. Okay, it decreases more rapidly with the height. Like this it is. Like this it is. For example, so here what we have is this. So for example, this in height h and this here depth d. All right. Now what is given to you is this acceleration due to gravity. So here the acceleration due to gravity is, for example, that is gd, and here the acceleration due to gravity that's equal to gh. Okay. So acceleration due to gravity that decreases with the height, that decreases with the depth, but decreases more rapidly with the height compared with the depth. All right. तो वो आपको ध्यान में रखना है बेटा. Okay. Okay. The acceleration due to gravity at a height of 1 kilometer above the earth is same, so that means this is equal to 1 kilometer. All right, is same as that of the depth d. You are supposed to calculate what's the value of this d. ठीक है ना बेटा? Okay, and what is given to you is that this gh and gd that is same. Okay, उसके लिए आपको इक्वेशन याद होनी चाहिए बेटा. That is gh is equal to what? It is equal to g multiplied by 1 minus 2h divided by r. ठीक है ना बेटा? So this is your acceleration due to gravity at a height h, or this shows the variation of acceleration due to gravity with the height h. All right. Then the acceleration due to gravity with the depth that varies something like this by this equation g into 1 minus d divided by r. ठीक है ना बेटा? Okay. Now what is given to you is that this gh is equal to gd. ठीक है बेटा? gh is equal to gd. Now if we equate these two terms, first of all this g and d will cancel, and this r and r will cancel, 1 and 1 will cancel. ठीक है ना बेटा? So straight away what you can write is this d is equal to 2h. ठीक है ना बेटा? This implies that this d is equal to 2h. All right, or 2h is equal to d. This 2h, it will be equal to this d. ठीक है ना बेटा? Now what is given to you is that the height is 1 kilometer. So when this height is 1 kilometer, what about depth? Depth will be simply equal to 2 multiplied by 1, which is simply equal to 2 kilometers. So this is the answer to the problem. ठीक है ना बेटा? If acceleration due to gravity at height h is same as that of the d, simply 2h will be equal to d. This equation 2h will be equal to d. Now out of these two parameters, either h will be given to you or d will be given to you. In this very case, the h is given 1 kilometer. So that means the depth must be equal to 2 kilometers. That is it. That's it. That's the way we do the problem. Okay. Okay. So I'm sure ये आपको अच्छी तरह से समझ में आई होगी. Let's switch to another example, which is our example number 5. So let's try to work this out. ठीक है ना? Example number 5 is simply like this. Conceptual question है बेटा. If Earth stops rotating suddenly, the value of the acceleration due to gravity at a place other than poles would. ठीक? So first of all, आपको ये ध्यान में रखना है बेटा. What happens to the acceleration due to gravity due to the rotation of Earth? The value of acceleration due to gravity in general that decreases due to the rotation. All right. So acceleration due to gravity. So here I will write down that acceleration due to gravity, it decreases due to rotation. It decreases due to rotation. What we mean by that? That means if, for example, the Earth it is at rest, it is not rotating, and then the situation number second, the Earth is rotating. When the Earth is rotating, the acceleration due to gravity will be lesser compared to that acceleration due to gravity when the Earth is assumed to be at rest. All right. ठीक है ना बेटा? But the exception is poles. Exception is poles. ठीक है ना बेटा? The acceleration due to gravity at the poles is independent of rotation. Whether Earth rotates faster or it rotates slower or it does not rotate at all, in all these situations, the acceleration due to gravity at the poles is not going to change. That will remain same. All right. ठीक है ना बेटा? अब आपके पास ध्यान दीजिए बेटा, क्वेश्चन क्या है बेटा? If Earth stops rotating, if it stops rotating, then obviously the acceleration due to gravity it will increase. If it stops rotating, the acceleration due to gravity will increase, and the exception is the poles. Other than the poles, so it's given to you, exception the poles. So it will what? Acceleration due to gravity will increase. So this is the answer. Acceleration due to gravity will increase because when the Earth is at rest, acceleration due to gravity is 9.8 on the surface of Earth, and when the Earth is rotating, the acceleration due to gravity is less than that. All right. The exception is poles. वो आपको याद रखना है बेटा. Okay. Let's switch to another question. तो यहाँ ध्यान रखिए बेटा. So here we have this our question number 6. ठीक है ना बेटा? Asked in AIPMT. Okay, so let's try to work it out again. It's an important problem, but not that difficult, and asked in the AIPMT 2012. ठीक है बेटा? So this has been asked in the AIPMT 2012. तो पहले आप यहाँ ध्यान रखिए बेटा. The height at which the weight of a body becomes 1/16th of its weight on the surface of Earth you will have to calculate the height in terms of radius of earth where the weight of an object becomes 1/16. ये आपको यहाँ आपको एक बात का ध्यान रखना है बेटा, that is what will happen to the acceleration due to gravity will happen to the weight, but the mass will remain constant. Mass is not going to change with the height or with the depth, ठीक है ना बेटा, but what will change is the acceleration due to gravity, and you know that when the acceleration due to gravity, this W is in turn equal to mg, the weight of the object is also going to change. All right, okay. So what we have to do is that we have to see what is the height when the acceleration due to gravity becomes 1/60, ठीक है ना बेटा. अगर आपको याद होगा बेटा, there are two equations for the acceleration due to gravity with the height, ठीक है ना बेटा. That's like this. So let me write it down. Better is that we'll do it here. यहाँ ध्यान दीजिए बेटा. So let's do it here. Okay, so let's work it out here. यहाँ आप ध्यान रखिए बेटा. So acceleration due to gravity with the height, there are two equations. One equation is like this, that is equal to gr square divided by r plus h whole square. ठीक है ना बेटा? And this is a generalized equation. This equation is always true. Okay. But there's a special case, and the special case is this: if this h is very small compared to r. If this h is very small compared to r, in that case the acceleration due to gravity becomes equal to 1 minus 2h divided by r multiplied by g. Okay, ठीक है ना बेटा? We have discussed this equation already. ठीक है ना बेटा? जब हमने पढ़ा था the variation of acceleration due to gravity, perhaps in the lecture number 2. Okay. So next क्या है बेटा? This gh is given, it's equal to g divided by 16. Let me write it here. It's equal to g divided by 16. तो यहाँ क्या आएगा बेटा? It's equal to gr square divided by r plus h whole square. ठीक है ना बेटा? R plus h whole square. First of all, what will happen is that the g and g will cancel. Taking root on both sides, this will be here 1/4 will be equal to r divided by r plus h. ठीक है ना बेटा? Now go for the cross multiplication. It will be something like this. R plus h will be equal to 4 times r. Then 4r minus this r is equal to 3r. So the answer is simply h is equal to 3r. So at a height of 3r, the acceleration due to gravity will become 1/16 times the acceleration due to gravity on the surface of Earth. ठीक है ना बेटा? So that was our question. Okay. So let's move back to the question. So this was our question. So ये था आपके पास बेटा question. So answer is what? That's equal to 3r. Isn't it? That's equal to 3r. All right. Okay. So the answer is what? That's equal to 3r. ठीक है बेटा? So this is the answer of the problem. That's equal to 3r. All right. ठीक है ना बेटा? Okay. So answer is simply what? That's equal to 3r. Now let's switch to another question. यहाँ आप ध्यान रखिए बेटा. The question number 7 here, and that to ask with the NEET 2018, and this question has been asked in what? That has been asked with the NEET 2018, and it's conceptual question. कोई इसमें mathematics है ही नहीं. ठीक है ना बेटा? तो आप थोड़ा ध्यान रखिए बेटा यहाँ पर. If mass of sun were 10 times smaller, number one is that the mass of sun is decreased 10 times. All right. And then g were 10 times larger in magnitude. So g is increased 10 times. G is increased 10 times larger. ठीक है ना बेटा? Which of the following statement is not correct? ठीक है ना बेटा? NEET 2018 question है बेटा. Okay. Option number A: raindrops will fall first. The acceleration due to this value of g, capital G, it is made 10 times. Then which of the following options is true? Option number A: raindrops will fall first. B: walking on the ground would become more difficult. C: time period of the simple pendulum on the earth would decrease. D: g on the earth will not change. So आपको देखना है incorrect कौन सा है. ठीक है ना बेटा? तो सीधे आपको करना है क्या बेटा? acceleration due to gravity है क्या बेटा? That's equal to gm by r square. Where m is the mass of the, for example, earth, r is the radius of the earth, and g is what? That is gravitational constant. ठीक है ना बेटा? Now what is given to you is that this g is increased 10 times, g by 10 times. If this g is 10 times increased, so acceleration due to gravity you have it, it will also increase 10 times, obviously, because it is directly proportional to this capital G. If this capital G is made 10 times, so obviously the acceleration due to gravity will increase 10 times. Obviously, ठीक है ना बेटा? And when this acceleration due to gravity will increase 10 times, that means that this acceleration due to gravity will become something like 98 meter per second square. ठीक है ना बेटा? 98 meter per second. Its actual value is 9.8, so its value is going to become 9.98 meter per second square. ठीक है ना बेटा? Now obviously what will happen is that when the acceleration due to gravity will increase, the raindrops will fall first. So this is correct. They will fall first. Okay. In the normal situation, they are falling downwards with an acceleration of 9.8. Now they will fall downwards with an acceleration of 98. Obviously, walking on the ground would become more difficult. That's also true because the weight of the object will increase when acceleration due to gravity will increase. So mg will increase. When mg will increase, for a person walking on the surface of earth, it will become more difficult for him. ठीक है ना बेटा? So this is also correct. Time period of the simple pendulum on the earth would decrease. It would decrease. Let's see what's the equation for the time period. What's the equation for the time period? So equation for the time period is something like this: T is equal to 2 pi root of L divided by G. Root of L divided by G. ठीक है ना बेटा? 2 pi under root of L divided by G. So this is the equation. All right. Now acceleration due to gravity is going to increase. When G will increase, so time period will. So G increases, inverse relation is there. Time period will decrease. So time period of the simple pendulum on the earth would decrease. So this is also correct. ठीक है ना बेटा? G on the earth will not change. How is it possible? We have seen that G will increase 10 times. So this is the incorrect statement and is the correct option. Because the reason is this, that आपको ये देखना, आपको ये नहीं देखना कि which of the following is. Normally students यहाँ पर एक गलती करते हैं बेटा. They quickly see, they don't see it clearly that it's not correct. What they see is that it's correct. फिर वो option number A देखते हैं. Then raindrops will fall fast and then they switch to the option number A. बिना ये B, C and D, they don't go to the B, C and D. They skip this not here and they don't go B, C into B, C, D. And वो जो option number A है उसी को टिक देते हैं which is incorrect. ठीक है ना बेटा? So the correct answer is G on the earth will not change. It is incorrect. It's indeed incorrect. But here we are supposed to calculate. We are supposed to say which of the following options are incorrect or not correct. ठीक है ना बेटा? Okay. So easy सा question है बेटा. NEET 2018 में आया था. Let's switch to another example. तो यहाँ ध्यान रखिए बेटा. Example number this one. Okay. So this is the next example. ठीक है ना बेटा? जो ये example है ना बेटा, question number 8 जो ये example है. If I will not exaggerate, this graph has been asked almost 10 to 12 times in NEET and JEE and AIMS till now, spanning from the electrostatics to gravitation to magnetism. ठीक है ना बेटा? This graph has been asked at least 10 to 12 times. ठीक है ना बेटा? At least. Okay. ठीक. So the question is simply like this: starting from the center of Earth, having radius capital R, the variation of acceleration due to gravity is shown by. You will have to simply plot G versus R graph. Okay. Let's have a bit of discussion on this. ठीक है ना बेटा? So let's have a bit of discussion on this. यहाँ आप ध्यान रखिए बेटा. So it's like this. Okay. Concentrate here. It's something like this. So for example, this Earth. ठीक है ना बेटा? This Earth. All right. Now this is the center of Earth. Now at the center of Earth, the acceleration due to gravity is equal to 0. What is that? That's equal to 0. All right. The acceleration due to gravity on the surface of Earth, that is, you know that that's equal to gm divided by r square, and this value comes out to be 9.8 meter per second square, and this is the maximum value of the acceleration due to gravity. Okay, maximum value of the acceleration due to gravity, possible value is what? That is 9.8, and that too on the surface of Earth. All right. Then at this very point, यहाँ आप ध्यान रखिए बेटा. So this is for example at this very point, what the acceleration due to gravity, तो वो मैं यहाँ पर लिखूँगा बेटा. Acceleration due to gravity is equal to G capital M divided by small r square, and true when small r is greater than capital R. That means outside the sphere or outside the Earth or above the Earth, the acceleration due to gravity is what? That's equal to Gm by small r square. ठीक है ना बेटा? Okay. And inside it's something like this. Gm divided by capital R cube multiplied by r. ठीक है ना बेटा? Or we can write it like this as well. This gm by r square is what? Acceleration due to gravity on the surface of Earth. So it is something like this: g small r divided by capital R. Something like this it is. So this is the acceleration due to gravity, and this is true when small r is less compared to capital R. ठीक है ना बेटा? This is true when small r is less compared to capital R. Okay. Now at the center it's obviously equal to 0 because small r is equal to 0. Inside it's directly proportional r. You see the directly proportional r. Outside it is proportional 1 divided by r square. Inside it is directly proportional to r. At the center it's equal to 0. तो इसका ग्राफ होगा क्या बेटा? The graph will be simply like this. यहाँ आप ध्यान दीजिए बेटा. What will be the graph? So here we have this acceleration due to gravity, and it varies with the radial distance from the center of Earth. So this point here, this is small r equal to 0. That means this is the center of Earth, and this here small r equal to capital R. It means that it is the surface of Earth. ठीक है ना बेटा? Acceleration due to gravity is minimum at the center of Earth. How much that is? 0. You move from center to surface, acceleration due to gravity increases, becomes maximum at the surface. You move away from the surface or upwards, acceleration due to gravity will decrease as 1 by r square. So that means what we expect is that the graph must be here linear. It must be a linear graph like this, and then from surface onwards it is something like this, what we call as rectangular hyperbola. All right. So that means this g inside is directly proportional to r, and outside it is proportional to what? It's proportional to 1 divided by r square. अब जो ये वाला ग्राफ है ना बेटा, ये आपको याद होना चाहिए. Okay, the reason is this: variation of acceleration due to gravity from the center of earth with radial distance. ये वाला ग्राफ. Variation of gravitational field from the center of earth, same graph. Variation of electrostatic field because of a uniformly charged solid sphere, same graph. Variation of, यहाँ ध्यान रखिए बेटा, variation of this magnetic field due to a solid current carrying wire, exactly same graph. ठीक है ना बेटा? Okay, so multiple number of times this graph is repeat again and again. So what you must do is that you will have to memorize this graph. तो जो बेटा ये आपके पास ये ग्राफ है ना बेटा, you will have to memorize it. Okay, it must be inside your brain always. All right. Now let's switch to another example. यहाँ आप ध्यान दीजिए बेटा. So let's switch to another example. Okay. So this was your question number 8. Question number 8. ठीक है ना बेटा? तो इसका अगर ग्राफ आपको प्लॉट करना है बेटा, so its graph will be simply what? That will be something like this. Simply the graph will be like this. First of all, it will be linear and the rectangular hyperbola. ठीक है ना बेटा? तो ये इसका ग्राफ होगा. Okay. So let's switch to another example. हमारे पास बेटा example number 9 है. Example number 9 का ये ग्राफ आएगा बेटा. You see that example number 9, similar graph. Okay, but there is slight difference, and that's like this. वो हम यहाँ discuss करेंगे बेटा. Okay. So let's discuss that. Let me discuss it here. यहाँ ध्यान रखिए बेटा. Let me discuss it here. All right. Okay. So gravitational field. यहाँ ध्यान रखिए बेटा. Again, this is what this earth. ठीक है ना बेटा? Again, at the center point, what is the gravitational field? That's equal to 0. Gravitational field. ठीक है बेटा? Inside and outside. Here, the gravitational field will be again equal to gm divided by small r square. Inside, you want to calculate what is the gravitational field. That will be equal to gm multiplied by small r divided by capital R cube. All right. Okay. ठीक है ना बेटा? ये r cube. आप ऐसे भी याद रख सकते हो बेटा. That means this equation must be dimensionally correct. It must be dimensionally correct. ठीक है ना बेटा? But by convention we are taking, since this gravitational force is always attractive in nature, so the gravitational field will be always directed radially inwards. Hence, by convention we always take it negative. All right. So that means this gravitational field is negative and this also negative. ठीक है ना बेटा? So obviously what you see is this. That this gravitational field is directly proportional to small r when this small r is less than capital R, while this capital R is the radius of the earth. All right. ठीक है ना बेटा? And this gravitational field is proportional to 1 by r square when this small r is greater than capital R. ठीक है ना बेटा? Okay. That it being negative, so the graph will be something like this. The graph ऐसे इसका होगा बेटा. So graph will be something like this. So this is here E versus R. This is here E versus gravitational field versus R. All right. At the center point, the gravitational field is equal to 0. Then it increases linearly. Since it is always negative, so we plot in the fourth quadrant. So like this, the graph is like this. ठीक है ना? Okay, so graph is like this. Okay. अगर आपके पास 4 options बेटा दिए गए हैं, and in all the 4 options, the 4 graphs are here, and all the 4 graphs are the fourth quadrant, then this is the correct answer. ठीक है ना बेटा? अगर आपके पास for example 4 options दिए गए हैं, and all the 4 options, the 4 graphs are in the first quadrant, that means you are supposed to plot the magnitude of gravitational field with respect to the radial distance. In that very case, answer इसका ये होगा. It's not surprising, it is quite obvious. ठीक है ना बेटा? तो graph style ये होगा. This will be between mod of E versus R. The graph will be something like this, and this will be equal to capital R. All right. ठीक है ना बेटा? Okay. ठीक. So graph is similar. You must know that this acceleration due to gravity and the gravitational field, their magnitude, their direction is always same at any point. That is same, but they are two different physical quantities. It does not mean that they are same physical quantities. They are two different physical quantities. All right. ठीक है ना बेटा? ये आपको पता होना चाहिए. Okay. So next what we have is this. We have this question number 10 here. So let's switch to the question number 10. यहाँ ध्यान रखिए बेटा. Let's switch to question number 10. Okay. So dependence of intensity of gravitational field. Again, we have to plot this gravitational field. You have to plot the graph between the gravitational field, ठीक है ना बेटा? Between intensity of gravitational field or gravitational field, one and the same thing. Of thin spherical shell. This is a thin spherical shell of radius capital R with distance small r from the center of the shell is correctly represented by. You will have to plot that graph. All right. Okay. तो यहाँ ध्यान रखिए बेटा. Again, the graph is not that difficult. It's quite easy. And we'll do it. यहाँ आप ध्यान रखिए बेटा. Okay. So here we have what we have is this. For example, this is a hollow sphere, ठीक है ना बेटा, this is a hollow sphere, okay, so that means the mass is concentrated on the only on the surface of the sphere. Inside it is vacuum, inside there is no mass at all, okay, so obviously its radius is given that equal to capital R, ठीक है ना बेटा. So what will be the this gravitational field intensity inside, that will be obviously equal to 0. Inside will be what? It will be equal to 0. Outside इसका mass अब है बेटा कितना m. So outside, for example, at this point which at a distance of small r from the center, you want to calculate what is the gravitational field intensity, that will be equal to gm divided by small r square, ठीक है ना बेटा, इतना तो आपको पता है, okay. So this will be the gravitational field intensity, gm divided by r square. Now if you want to plot the graph will be simply like this. यहाँ ध्यान रखिए बेटा, let's try to plot mod E, magnitude of gravitational field versus the radial distance. This here is 0, that is the center, and this here capital R, which is the center, ठीक है ना बेटा. Now at the center, what is the gravitational field? That's equal to 0. As you move from center to surface, what is the gravitational field intensity? That is 0. That is 0, ठीक है ना बेटा. So the graph will be something like this. तो ये वाला इसका graph होगा. So it will remain 0 from center to surface. Then thereafter it will be non-zero. Just outside it will be non-zero. And here outside it is proportional to 1 divided by r square. So E versus R graph will be a rectangular hyperbola graph. It will be a rectangular hyperbola. ठीक है ना बेटा. इसी तरह से होता है बेटा. For example, if we talk of electrostatics. Okay, so you can say safely that the electrostatics and the gravitation, they are like two twin sisters with a bit of difference between them, ठीक है ना बेटा. Okay, अगर आपके पास for example एक charged sphere है बेटा, for example, so this charged sphere, uniformly charged hollow sphere, isn't it? Uniformly charged hollow sphere, its radius is capital R. Inside the electrostatic field will be equal to 0, ठीक है ना बेटा. And outside the electrostatic field will be similar. G के बदले यहाँ आएगा बेटा K, m के बदले यहाँ आएगा बेटा q, r के बदले आएगा बेटा r square. So the field will be equal to k divided by r square. And if you want to plot this electrostatic field versus r graph, again it will be 0 inside, outside rectangular hyperbola. The graph will be something like this, similar graph, ठीक है ना बेटा. So there is a connecting link between the electrostatics and the gravitation, ठीक है ना बेटा. That is why जब भी हम स्टूडेंट जो होते हैं ना इसमें NEET class में, we first of all go for the electrostatics, and just after the electrostatics we go for the gravitation, ठीक है ना बेटा. The reason is that there is a connecting link between this electrostatics and gravitation. All right. So next is question number 11. Again it is important, तो यहाँ अब ध्यान रखिए बेटा, it is an important question, question number 11. So let's switch to the question number 11. Okay, a nice question it is. Imagine a new planet having the same density as that of the Earth. What is given to you is that the density is same, ठीक है ना बेटा. So what is given is that density is same, okay. So same density as that of the Earth, same density. There are two planets, one Earth, another is some new planet. So their density is what? Same, but it is 3 times bigger than the Earth in size. That means its radius is 3 times bigger. 3 times bigger, okay, ठीक है ना बेटा. And 3 times bigger in size, so that in radius it is 3 times bigger. If acceleration due to gravity on the surface of Earth is g, you know that is g. Then and that on the surface of the new planet g dash, then you will have to write down the g dash in terms of what? In terms of g, ठीक है ना बेटा. But what is given as the same is the is density, okay. So let's try to work it out. Let's try to work it out. 3 times radius है बेटा. So it's like this. It is like this. यहाँ आप ध्यान रखिए बेटा. What is the question? The question is something like this. So for example, here we have there are two planets. There are two planets, okay. So for example, the density of the planet P is equal to the density of the Earth. Density of the Earth, it is given to you, and then the radius of the planet P is equal to 3 times the radius of the Earth. 3 times the radius of the Earth, ठीक है ना बेटा. And you are supposed to calculate this GP. What is the acceleration due to gravity of the surface of the planet in terms of g, ठीक है ना बेटा. तो उसके लिए आपको क्या पता होना चाहिए? You must know what is the relation between the acceleration due to gravity and the radius and density as well, ठीक है ना बेटा. So what's the expression for the acceleration due to gravity? That's equal to gm divided by r square, ठीक है ना बेटा. gm divided by r square. Then the wrong thing you can do here is this. The wrong attempt you can make this is that the g is inversely proportional to r square. So what you will write is this g1 by g2 is equal to r2 square divided by r1 square. लेकिन उसके from there you can come out with an answer. From there you can come out with an answer, and that answer will be definitely among the options. That answer will be definitely among the options, ठीक है ना बेटा. असल में होता क्या है बेटा? For example, there is a question that's asked in the competitive exams, and obviously there are 4 different options given to you at the end of the question, ठीक है ना बेटा. जो उनमें से एक ऑप्शन तो करेक्ट होता है, अप्रोप्रिएट एक ऑप्शन होता है. तीन ऑप्शन जो होते हैं दे आर इनकरेक्ट, ठीक है ना बेटा. बट दोज थ्री ऑप्शंस दोज आर नॉट गिवन एज सच, ओके. दे आर नॉट, दोज थ्री ऑप्शंस आर नॉट इलॉजिकल, ठीक है ना बेटा. दोज थ्री ऑप्शंस आर नॉट इलॉजिकल, ओके. इन एवरी ऑप्शन देयर इज अ ट्रैप, okay. For example, if you will make an error and then from that error you will come out with an answer, okay. तो जो आपका आंसर वो निकलेगा, जो गलत आंसर होगा वो भी ऑप्शन में से एक ऑप्शन होगा, ठीक है ना बेटा. So among the three remaining three options there are three different traps, okay. So now it's up to you whether you are going to fall in the trap or you are going to work out the right way to solve the problem. यहाँ आप ध्यान रखिए बेटा. So first of all you see that the density is constant. It's not given that the mass is constant. What is given is that density is constant. So what you can write is this. You can write down the equation like this: g divided by r square. Mass के बदले आप लिख सकते हैं बेटा volume into density, isn't it? So now you know that the volume of a sphere is 4 divided by 3 pi r cube multiplied by density is rho. All right. Now this r square is going to cancel with this. So what I can say is this g is directly proportional to r multiplied by rho. ठीक है ना बेटा. So in this very case that means that g is directly proportional to r. G is directly proportional. ठीक है ना बेटा. So how g depends on the r? How g depends on the r? It depends on how g is proportional to the r. It will depend on which of the following parameters are constant. Is mass constant? Then g is proportional 1 divided by r square. Is density constant? Then the g is directly proportional to r. तो वो आपको देखना पड़ेगा बेटा, ठीक है ना बेटा. So g is directly proportional to r, ठीक. Now directly proportional का मतलब सीधे सीधे, so this implies that this gp जो है बेटा that will be equal to 3 times acceleration due to gravity on the earth, or this is g dash is equal to 3 times g. That's it, the problem is done for us, ठीक है ना बेटा. Okay, so I'm sure ये क्वेश्चन भी आपको अच्छी तरह से समझ में आया होगा. Okay, so let's check out that question. तो आप यहाँ ध्यान दीजिए बेटा. So this was your question, okay. तो इसका जो correct answer है बेटा that is g dash is equal to 3 times g. So this is the correct answer, ठीक है ना बेटा. तो ये आपके पास रहा बेटा correct answer, okay. So this was your question number 11, okay. So let's switch to another question. Yes, question number 12 as well. Question number 12, ठीक है ना बेटा. So this question number 12 has been asked in the NEET 2019. Let's try to work it out here. So body of weight is given to you that's equal to 100 Newton, ठीक है ना बेटा. On the surface of Earth, how much will it weigh? Halfway down to the center of Earth, ठीक है ना बेटा. How much will it weigh? Halfway down, ठीक है ना बेटा. Without using any mathematics, you can do it directly. एक point आपको याद होना चाहिए बेटा that acceleration due to gravity decreases with the depth. It decreases with the depth. 200 है, ठीक है बेटा. तो 250 और 200 इसका आंसर हो ही नहीं सकता. तो आंसर या तो होगा 100 न्यूटन या तो होगा 150 न्यूटन, ठीक है ना बेटा. पॉइंट नंबर 1. पॉइंट नंबर 2 इज दैट जो एक्सेलरेशन ड्यू टू ग्रेविटी है ना बेटा, एक्सेलरेशन ड्यू टू ग्रेविटी दैट डिक्रीजेस लीनियरली विद द डेप्थ, ठीक है ना बेटा. ओके, सो व्हेन इट्स हाफ वे डाउन तो सो सिंपली 200 डिवाइडेड बाय 2 दैट विल बी इक्वल टू 100. सो आंसर इसका 100 आएगा, ठीक है ना बेटा. सिंपली इट्स लाइक दिस इट इज. फॉर एग्जांपल दिस अर्थ, दिस इज द सेंटर ऑफ अर्थ. यहाँ पर एक्सेलरेशन ड्यू टू ग्रेविटी 0 होगी, और जहाँ पर एक्सेलरेशन ड्यू टू ग्रेविटी 0 होगी वहाँ पर वेट ऑफ द ऑब्जेक्ट विल बी आल्सो इक्वल टू 0. नाउ हियर इज गिवन दैट द वेट ऑफ द ऑब्जेक्ट इज इक्वल टू 200, ठीक है बेटा. तो जहाँ पर एक्सेलरेशन ड्यू टू ग्रेविटी 0 होगी, फॉर एग्जांपल, so here it is 0, so here what it will be is that the weight is equal to 0. So what about the midpoint? Then at the midpoint the weight will be simply equal to 100 Newton. तो इसका हाफ होगा, ठीक है ना बेटा. So the answer is 100 Newton. Without using any calculation and all that, you can straight away do this example. Let's switch to another example. Okay, example number 13 is there. Example number 13. यहाँ ध्यान रखिए बेटा. Example number 13. What will be the effect of weight on a body placed on the surface of Earth if Earth suddenly stops rotating? If it stops rotating, what will happen to the weight of the object? अगर आपके पास mass है बेटा, then no effect will be there. Okay, but here is weight. So first of all, acceleration due to gravity, when it will stop, acceleration due to gravity will increase. When that will increase, so the weight of the object will increase. So the weight will increase. Simply जो B part है बेटा वो इसका आंसर है. Question is asked in AMS 2014. Next question देखिए बेटा. Next question जो है बेटा that's asked in AMS 2012. ये question पूछा गया बेटा AMS 2012 में. Find out the correct relation for the dependence of change in acceleration due to gravity. Change in acceleration due to gravity on the angle at the latitude due to the rotation of Earth. तो उसके लिए आपको पहले ये पता होना चाहिए बेटा that g dash is equal to, ये हमने already निकाल के रखी है बेटा, g dash is equal to g minus r omega square cos square theta, अगर आपको अच्छी तरह से ये पता हो, ठीक है ना बेटा? Okay. Now if you want to calculate, for example, delta g, the magnitude of the delta g, magnitude of, that's obviously equal to what? That's equal to r omega square cos square theta, ठीक है ना बेटा? Change in acceleration due to gravity. Now you see that how it depends upon the latitude. This delta g, magnitude of delta g is directly proportional to cos square theta. तो ये है इसका आंसर, ठीक है ना बेटा? So this is the answer to this problem. All right, okay. कोई rocket science इसमें नहीं है बेटा. Asked in M12, you can expect such a question to be asked in the NEET as well. ठीक है ना बेटा? लेकिन एक ऑप्शन डेफिनेटली यहाँ पे cos थीटा होगा, तो आपको ध्यान रखना है बेटा, वहां पर cos थीटा नहीं है, वहां पर cos स्क्वायर थीटा है, ठीक है ना बेटा? Okay. So next question देखिए बेटा, question number 15 here, and this question number 15 has been recently asked in the NEET 2020. All right, okay. तो आप यहाँ ध्यान दीजिए बेटा, a body weighs 72 Newton on the surface of Earth. What is the gravitational force on it at height equal to half the radius of the Earth? Half the radius of the Earth. ठीक है ना बेटा? Okay. So simply what you have to see is that let's see how the acceleration due to gravity varies with the height. तो आपके पास एक इक्वेशन है बेटा, that is gh किसके बराबर है बेटा? gr square divided by r plus h whole square. ठीक है ना बेटा? r plus h whole square. Then you have to calculate its weight at what height? At half the radius. At half the radius means that h is equal to what? h is equal to r by 2. ठीक है ना बेटा? So here it is given to you that half the radius. So this will be here what? This will be gr square divided by, यहाँ आएगा बेटा ये r plus r divided by 2 whole square. R divided by 2 whole square. ठीक है ना बेटा? Now you see this will become 3r by 2. 3r by 2. R square is going to cancel with r square. 3r by 2 यहाँ पर आएगा बेटा 9 by 4. तो वो आएगा बेटा यहाँ पर 4 divided by 9. When you calculate it comes out to be something like this, 4 by 9 g. ठीक है ना बेटा? Now the weight at the earth, at the height h will be equal to 4 by 9 times the weight of the surface of earth. And what's that? That is 72. ठीक है ना बेटा? Now it will be like this, 9 1 9 8 8 4 is 32. तो आंसर इसका आएगा बेटा 32 न्यूटन. ठीक है ना बेटा? तो ये रहा इसका आंसर 32 न्यूटन. All right. Simply we have used this equation that the acceleration due to gravity at that height will be 4 by 9 times g. So the weight will be also 4 by 9 times the weight of the surface of earth. That is 72. So this will be equal to 32 Newton. तो ये रहा आपके पास आंसर इसका. ठीक है ना बेटा? ये 2020 वाला क्वेश्चन है. ओके. So then here we have this question number 16. Question number 16. Okay. Question number 16 जो है आपके पास, that's like this, the height at which the acceleration due to gravity becomes g by 9 in terms of radius is. So simply again you will use the same equation. gh किसके बराबर होता है बेटा? gr square divided by r plus h whole square. ठीक है ना बेटा? And then it is given to you this here g by 9. So let me write it. g by 9 is equal to what? That's equal to gr square divided by r plus h whole square. All right. ठीक है ना बेटा? Okay. So then taking g and g will cancel, taking root of both sides. So this will be 1 by 3. Then go for the cross multiplication. तो आएगा बेटा r plus h is equal to 3r. And this means that h is equal to twice r. So this is the correct answer. ठीक है ना बेटा? Okay. I'm sure this is also clear to you. Asked in EEE 2009. Okay. So there's question number 17 as well. Question number 17. जो question number 17 है ना बेटा, we have done this already. Okay. We have done this already. Okay. So simply what is the change in the value of the acceleration due to gravity at height h above the surface of earth is same. So it is same at the depth. So that means simply what is given is that this gh is equal to gd. Whenever gh will be equal to gd, this 2h will be equal to d. That's it. 2h will be equal to d. ठीक है ना बेटा? So 2h will be equal to d. तो ये रहा इसका आंसर. ठीक है ना बेटा? With no time you can do this question. Okay. So here we are done with what? With our topic. So we are done with the topic of acceleration.